All right, good morning. Welcome back. A few things updating-wise, schedule-wise. I've got it on the screen right here. You guys know you can find this on Blackboard at any time. Today we're going to talk about section 2.6 from our algebra unit. On Monday, we'll finish 2.6 and talk about 2.7. And on Wednesday, I'm going to give you your first test. Okay? You guys have lots of things that are due before Wednesday. Namely, I keep preaching to you about this. There is a quiz for section 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, and 2.7, right? We are basically done with section 2.5. What does that mean? You should be close to done with 2.1, 2.2, 2.3, 2.4, and 2.5, roughly. Some of you haven't even finished 2.1, okay? You are way behind, way behind. Okay, when is all of that due? Wednesday. Now, keep this in mind. If you add up the points for the 2.1 quiz and 2.2 and 2.3 all the way through 2.7, it adds up to 63 points. Your test is only worth 75. Okay? So the score that you get on all of those quizzes is roughly equivalent in importance as your test score is. So you should be taking those quizzes seriously, especially since I give you a chance to redo them over and over again until you get a perfect grade. Right? So I'll stop preaching at you again. But some of you are very, very far behind when it comes to those quizzes. So you have a lot of work to do between now and Wednesday. The other thing that will be due on Wednesday is that spreadsheet that I showed you last time that you have to code. Okay? When you turn that in, you're going to turn it in by saving it into your shared folder, so that I can go access and I can check it out. Now, I'm going to check it for accuracy. However, you should not have to save it in there and say, hey, can you check to see if this works? Because you should be able to check to see if it works, right? And what do I mean by that? Like right now, this one isn't coded at all. But let's say I punch in a 4 and a 7 and a negative 13 or something, negative 11, something like that. 4x squared plus 7x minus 11 equals 0. You should be able to solve that equation with your paper and pencil. Maybe you can factor it. Maybe you can complete the square. Maybe you can punch it in GeoGebra and see where it crosses the x-axis. Okay? You should be able to solve that. And if you can solve it and write your answer down on a piece of paper, it should match the answer that you get here. And if it doesn't, your spreadsheet doesn't work, right? So then try another one, and try another one, and try another one. You should be able to try 5 or 6 or 7 different examples in your spreadsheet. And if every time you're getting the solutions that you also get on paper, then I would say you'd be pretty confident that your spreadsheet works, right? Here's the other thing. If I do it on tab number 1, and then go over to tab number 2, and I do the exact same problem, 4, 7, and negative 11, what should happen in the long run? Same answer. Because completing the square and using the quadratic formula are the exact same thing. We demonstrated that last time, right? So if you're getting different answers on one tab than you are on the other tab, one of them is wrong, if not both of them, right? So if you're having trouble with, hey, I really want a certain number to spit out in this blue field, but I can't code Excel to get that number to spit out, I can help you with that. But I don't want you to say, hey, can you check to see if my answers are correct? That's different, right? So if you turn this in and yours is garbage, I'm going to give you a chance to redo it and make edits to this, okay? So you got to at least turn something in by Wednesday, right? So I can go through and I can check it. And there's a rubric in Blackboard, and I'll give you a score for accuracy and blah, blah, blah. You can see that rubric. And then once you see the score I gave you, I can give you a little tip or a note, and I can say, hey, you know what? Your J10 is wrong, or something like that. Or you missed a negative sign in your G12. Double check, and I'll help you along. But I want you to get to the point where this thing actually works for you.
Turning it in is just putting it in the shared folder.
Correct. Yep, put it in the shared folder, because sometime Wednesday, actually I'll probably do it while you guys are doing your test. I'm going to go into your shared folder and I'm going to start looking at what you saved in your shared folder. Yep. But don't stress if you put it in there and it's like, this thing just isn't working right now. I'm going to give you a chance to keep working on it. Okay? Any questions on that? Okay, so that's all due Wednesday. So let's get to where we're going today. So remember where we're at right now. All we're doing in this algebra module 2 here is we're really just solving equations, okay? So let me just recap where we've been and where we're going. We're solving equations. What have we done thus far? We started out with linear equations, which were kind of the easier ones, and my little bullet says there's nothing special about x. We're just trying to get x by himself, right? Then we went to rational equations. How do you spot a rational equation? It's a ratio, it's a fraction. So our x, or our variable that we're trying to solve for, is going to be in the denominator. And how did we tackle those? First, we had to watch out for dividing by 0. We know that we can't divide by 0. And we were using like finding the lowest common multiple of the denominator, multiplying both sides. We practiced a bunch of those, right? And some of those are in your quiz. Then we went to quadratic equations. How do you spot a quadratic equation? X is squared, okay? And we had all kinds of strategies for that. Maybe I can factor it and use the zero product principle. Maybe I can use the square root property, namely just taking the square root of both sides of the equation. That's a possibility. Maybe if that doesn't work, I can complete the square. We spent a day and a half on that, right? And completing the square is actually the same as using the quadratic formula, which is just a plug and chug, right? Plug some numbers in and pull out a calculator and do some arithmetic. Or I could graph it, and I could see if it actually crosses the x-axis anywhere, and if it does, those are my solutions. If it doesn't, then we know that it's imaginary. So I know we went through that fast. It's a high school algebra review, and we covered, if this was a high school algebra 2 class, we would have spent 3 weeks on that. We spent 3 days, okay? So if you got to figure out where you are at with your comfort level of that. Like, I really remember this stuff from high school and it's easy, or I really got to do some practice, okay? Every one of you is going to be in a little bit different boat there, okay? So here's where we're going next, our section 2.6. It's kind of like a bunch of different types of equations, and we're going to talk about some different ones. What about polynomial equations of degree 3 or higher? Remember, a linear equation is x to the first power. A quadratic equation is x to the second power, x squared. Well, what about x to the third, or x to the fourth, or x to the fifth, or x to the sixth? Okay, so higher order ones. Radical equations, what are those? Those are equations that have square root signs in them. Like the square root of x equals something, and we have to get rid of the square root sign. We'll talk about that briefly here. Equations with rational or fraction exponents. So we can do x to the first, x to the second, x to the third. What happens if we have x to the 2/3 power, or x to the 3/7 power? Our exponent might not be a whole number, it might be a fraction. So we're going to practice those a little bit. An absolute value equation. The absolute value of x is equal to something. We'll talk about absolute value. So here's just a few things, and I put this PowerPoint up on Blackboard. You can always look at this again. I'm going to give you some tips and some strategies, and then I'm just going to throw a bunch of equations at you, and we're going to spend the rest of the day practicing solving different types of equations, okay? So here's a few tips. Let's look at these 4 that I just put up here and talk about each one here. What about these polynomials of degree 2 or higher? Okay. For example, there's a whole linear factorization theorem that says if you have an equation that is a quadratic x squared, you can factor it into 2 parentheses, 2 binomials, 2 linear factors. That's what we do when we factor quadratics, right? We go from one quadratic and we factor it into 2 parentheses. Well, what happens if it's x to the third? How many parentheses are we going to get? 3. What happens if it's x to the fourth? 4. X to the fifth? 5. That's what we call the linear factorization theorem. So what we want to do, if we can, is we take this equation and we try to change it into a parentheses times a parentheses times a parentheses times a parentheses times a parentheses, blah, 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 blah. However many parentheses we need, and we set the whole darn thing equal to 0. And then we can set each guy equal to 0. It's the same thing we do when we factor quadratics. It's just that we might have to do more than 2 of them, right? So we're going to practice, something like that. Set each of those parentheses to 0. Now, I can give you third degree and fourth degree and fifth degree equations that are not factorable by normal human power. Some of them are just impossible. And you got to use a graphing calculator or a computer algebra system to solve them. We're not going there. If we run into one that we can't visualize and see a structure or strategy, we're using technology to help us with that, right? We're just trying to understand some algebraic procedures, factoring, being able to rewrite things, stuff like that. So I said you got to be clever enough to recognize when certain guys are factorable and when they aren't. Okay, let's talk radical equations. These are the ones that have a square root sign in it, right? Very, very simple. Okay? In the previous section, we did x squared. We did quadratics, right? When you have an x squared and you're just trying to get down to an x, how do you take the square away? How do you change an x squared into an x? You square root it, correct? If I take x squared and I square root both sides of the equation, that gets rid of the square because a square root and a square cancel each other. They're inverse operations of each other, right? So if I take, what happens now if I have an equation that isn't x squared? What happens if it's the square root of x? How do you get rid of the square root sign? You square it because they're opposite operations, right? So you would square both sides of the equation. Not too bad? Okay? Because a square cancels a square root. So if you understood 2.5, you should be able to understand what we're doing here. Now I got one more bullet on here. It says, beware the extraneous solution. Some of you are like, what's an extraneous solution? I'll tell you what I mean by that. I'm going to give you an example. Let's say I told you that x was equal to 4. Just accept that as a fact. Okay? What does x equal? 4. Are we confident? X equals 4. Okay? Let's say I decide to take that equation and I decide to square both sides of the equation. Geez, I screwed my PowerPoint up. You guys already see my mistake? Duh. Let's fix that quick. That should be a 16, right? And what should this be? 16? How'd I do? Better? Okay, let's say I decide to square both sides of the equation. So if I square both sides, I would get x squared equals 16. Do you guys agree that that is a legal algebraic maneuver? Like, I didn't break any rules, right? Okay, so now that we're at x squared equals 16, and I told you solve for x, what's a good way to do that? Square root both sides, right? That's the square root property. And if I do that, notice what is my answer going to be? Because how many solutions are there to this guy? There's 2 answers. So what is my answer now? It's both plus and negative 4. So remember a few seconds ago we said x was equal to 4, right? But now I'm telling you that x is equal to 4 and negative 4. How is that possible? I started with 4. I did a legal maneuver and a legal maneuver, and now all of a sudden x is both positive and negative 4. Does that make any sense? What did I do? I created what we call an extraneous solution. I created a solution that wasn't even one of the solutions. And how did I create it? I did it when I squared both sides of the equation. So here's this kind of a rule of thumb. If you ever have an equation and you square both sides of the equation, or you take it to the 4th power or the 6th power or any even power, there's a possibility that you're changing a negative into a positive and you're masking it. And then later on you're going to find out that something looks like a solution, but it's not really a solution because you did that step. I know that might be a lot to swallow if you've never heard of that before, but we'll have an example where that comes into play. So that's my little slide on the extraneous solution. So the other ones that we talked about, equations with rational exponents. We want to solve for x. And when we solve for x, we mean x to the 1st power. But when we write x, we usually don't write the little 1. We just know that there's a 1 there, right? X to the 1st power. But what happens if we're given one that says x to some fraction? like m divided by n, or some numerator divided by a numerator. If you have a fraction, m over n, some fraction, and you want to change that fraction into a 1, how do you do it? Say again? You multiply by what we call the reciprocal, taking the numerator and the denominator and flipping it. And if I take a fraction times his reciprocal, I will get 1 every single time. Do you guys agree? Okay. So that's going to be a multiply by its reciprocal. That's going to be a skill that we're going to learn, right? So if I had something like x to the, I'll say 4/7 power, x to the 4/7 power, what do I need to do to that exponent to make it an exponent of 1? I would need to raise it to the power of 7/4. And of course, I'll have to do the same thing to the other side of the equation too, right? Whatever I do to the left, I got to do to the right. And now on this side of the equation, cancel, 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 I'm just left with x to the 1st power, right? Okay. Finally, I'm almost done talking at you here, so you can practice a few. Sometimes equations look like they're quadratic in form. So in section 2.5, we already know how to solve a quadratic equation. It says sometimes equations can be converted into a quadratic equation. You got to be a little bit clever, do a little bit of substitution. You'll be able to see that. It's got to be a little bit clever. And then absolute value equations. This really tricks a lot of students, okay? Absolute value. So my question here, before we even try to tackle an absolute value equation, what's a definition of absolute value? Anybody got something? Give me a definition. Go ahead, Isaac.
Isn't it like the value away from 0?
Fantastic. It's the distance away from 0 on a number line. You guys remember when you were little kids in your kindergarten room, there was a number line, and there was a 0 right here. Well, you probably didn't get the negative numbers until like 5th grade, so I shouldn't say kindergarten. But you had the negative numbers went this way, right? -2, -3, and so forth. And then the positive numbers went this way, 1, 2, 3, and so forth, right? So when I give you some value, and I call it the absolute value of 5, what is the absolute value of 5? 5. What is the absolute value of -5? 5. Exactly. So what I'm really saying is, instead of these vertical bars are absolute value. Okay? But if the absolute value concept tricks you up when you run into it in the course of one big, long, ugly equation, instead of saying the absolute value of 5, you can substitute the words in the distance away from 0 on a number line of 5, right? So I'm saying, how far away from 0 is 5? It's 5 units away, right? How far away from 0 is -5? It's 5 units away. It happens to be on the other side, but distance-wise, it's still 5, right? That's going to help you as you try to tackle some of these equations, okay? Now, there are exactly 2 values that are the same distance away from 0 on a number line. Do you guys agree? If I want to find, here's 0. If I want something that is 17.2 units away from 0, I can go 2 places on the number line. I can go to positive 17.2, and I can go to negative 17.2. So what do you think is going to often happen when you're solving an absolute value equation? You're probably going to get 2 answers. For example, the absolute value of x is equal to 12. Solve for x. You can do that one in your head. There's 2 answers. What are they? 12 and -12. There's 2 answers, right? Because there's both 12 and -12 are 12 units away from 0. Okay, very good. Okay, let's practice. On Blackboard, you're going to want to just take out a piece of scratch paper. I put this thing called 2.6 checkpoint examples. It's just a PowerPoint, and all it is like a worksheet. And I've given you these equations to work on. And these will take a while. Some of them will be quick. And I know we went over some of those tips really fast, okay? So you might have to review some of this. But here's one that is larger. It's larger than second degree, like that's a fourth degree equation. Here's one with a radical sign in it. Here's one with a fractional exponent. That's supposed to be 3/2 is up in the exponent, if that is tough to read there. Here's another fourth degree. Here's an absolute value. There's an absolute value. Other radical ones. What I'd like you to do is pull out a piece of scratch paper and just start trying to tackle these. I don't even care if you start with number 1. You start with whichever one you want. I'm going to walk around, help you out a little bit. If you have a question, I can give you a tip. If you want to talk to your neighbor, you can do that. I'm not going to have you hand this in. It's purely for practice. If you want to pull up this PowerPoint on Blackboard, you can. Or I'll just leave it up on the screen here. Everybody got them all done yet? Just kidding. So what would be a good thing? Yeah, I like what you did so far.
Okay,
So, yep. So what do you think here?
well, we've discussed
Yeah.
taking times like the reciprocal or square rooting it.
You could do both of those things. One thing that you might find, like if you square rooted it, you'd get x squared equals square root of 3x, right? What might end up happening in that scenario is you're going to end up losing some of your solutions. So let me have you think about this. If you're working on that first one, what they did here is, is we said, let's divide both sides by 4. That's what you did right away, right? So you got x to the 4th equals 3x squared. One thing we can do is try to move everything to one side of the equation and factor it. That's where I said we'd have different parentheses, right? Wow. Okay, so what happens if I went x to the 4th minus 3x squared equals 0? Is there something I can factor out now?
X squared.
Yeah, they both have an x squared in them, right? So I could pull out an x squared. What's left over?
X squared minus 3.
Yep, still equal to 0. And now I'm down to 2 parentheses. How many parentheses should I be able to get? Because it's a 4th degree equation, right? So I want 4 linear factors. So x squared actually could be x and x, could it not? Right? And then x minus root 3, x plus root 3. There. I just factored that whole guy into 4 parentheses. And I factored this guy into the difference of 2 squares. So if you FOIL these 2 guys back out, notice you get right back to that. It's a factoring trick. Yep.
So then, okay, I'm probably stupid, but I feel like it wouldn't be like x minus 3.
Root 3. So if you did x minus 3, x plus 3, that would actually be x squared.
No,
Which one's the one?
I don't know. I guess.
You're wondering how we got from here to here?
Yeah, like I don't know why you would put a square in it.
Yep. So it's a factoring trick. Factoring trick called factoring the difference of 2 squares. So you just have to recognize that if I take this and I FOIL it back out, x squared plus root 3x minus root 3x would cancel. And then minus root 3 times root 3 is 3. Yep, it's a factoring trick.
I'll just believe you.
That's why I gave you all that factoring practice stuff from the other day, right? I know it's a high school review, but it's like, oh, I haven't done this in a couple of years, right?
Yeah.
Which one were you going to ask about, Martin?
I was gonna ask.
That same one?
Yeah.
Yep.
Like there was like this thing I remember faintly from like
Mhm.
sophomore year of high school. It was
Sure.
Like 4x4. So
Mhm.
you would go like, you would take out the common multiple.
Yep.
You would go like.
Wait, what?
And that's what I did too.
4x2 times the x2 equals.
Yeah, I don't remember.
Oh no.
Yep, you're right. Yep. And now take
then it would
a,
be-
and then take an x squared out of the 12, so it'd be 12 times x squared.
itself is just what
x squared.
Yep.
You would go like that, and
Yep.
then it would like split in half, and then you would just do each side on its own.
Yep. So
I forgot. how to do that.
eventually what you're going to do, though, is you're going to want to set them equal to 0. And in order to set them equal to 0, everything's going to have to be on the same side of the equation. So that's what I did. Like you could divide by 4 right away, or you could leave the 4 there. It doesn't matter. But eventually what I did on that bottom line is I moved everything to the same side and set it equal to 0. And then, like you said, you can set up individual parentheses.
Yeah.
Yep.
Okay.
Yep.
Okay.
Hey, is that your answer?
Well, that's been factored. So when we do a quadratic, we do parentheses times a parentheses is equal to 0, and we said let's let that guy equal 0 and let's let that guy equal 0, right?
Yeah.
Well, now instead of having 2 parentheses, I have 4. 1, 2, 3, 4. But I knew I was going to get 4 because this is a 4th degree. So I can just say, let's let this guy equal 0. So one of my answers is 0. How about let's let this guy equal 0? So what's another answer? 0. That's one of those double answers, the double root. Let's let this guy equal 0. If this guy was equal to 0, what value would make this whole thing equal to 0? Root 3. Because root 3 minus root 3 is 0. So that's one of my answers. What value would make this guy equal to 0? Negative root 3. So how many answers did I get? 4 of them. Even though one was a double. a double root, right? So what did we do there? We didn't cure cancer, right? All we're practicing is algebraic manipulation. Can I factor? Can I move things around? Okay? It's a skill. It's just algebraic fluency is all we're really practicing with all of these. Those of you that might be working on the second one, very, very similar. This time it's a third degree equation. There's probably a few different ways you could go about factoring this. However, in the long run, how many answers are you going to get? 3. So if you can get it down to a parentheses times a parentheses times a parentheses equals 0, then the heavy lifting is done. If you can factor it. Once you get those 3 parentheses equal to 0, then it should be pretty easy. You just let each individual parentheses equal 0 and spit out your 3 answers. So see if you can get there.
So it's like this one, like I forgot what the next step would be after this.
So what I would probably do here, yep, so this is good. I'm trying to think. So what you could do here is eventually you want this whole thing to equal 0.
Yeah.
So maybe take all this garbage
move it to the left.
and move it over so you still have an x squared and a 2x plus 3. And then if I move all that over, it'd be minus 4 2x plus 3 equals 0.
It would just be x squared minus 4
Yes.
times 2x3 squared.
Nope.
No?
So now you're pulling out what each of these guys has a common factor, and it's the 2x plus 3, right?
Yeah.
So you're right. If I pull out the 2x plus 3, I pull it out. Okay. What's left over? X squared. And what's left over here?
4.
Minus.
Okay.
And now you're almost home free.
Yeah.
How many parentheses do you need? 3. Right now you have 2.
So
But this one,
it'll be x minus 2x plus 2.
absolutely.
And then 2x plus 2. Okay.
Absolutely. And then you have your 3 parentheses. Set them all equal to 0. You're home free. Yep. Nice job. What am I missing? Oh, I know what. Hold on 1 second. Sorry. All right, what do you got?
That's the only one I can't figure out. I don't know which one to multiply by.
So this is one of those that is kind of cleverly disguised as like as a quadratic. Like for example, if it was 3x squared minus 11x minus 4, you could probably handle it, right?
Right.
So if you do a little clever substitution, like let's say a lot of times when we do substitution, we'll use like the letter U or something like that. So let's say you said let U equal x to the third. So I've just made that up. I made up u, right? So if u was x to the third, what would u squared be? If I squared both sides of the equation, x to the 2/3.
Okay.
So what I'm doing here is I'm trying to take a complicated ugly and make it into something that I can handle, namely a quadratic equation.
Okay.
So if I rewrote this, every time I see an x to the 2/3, I'm going to write u squared, and every time I see an x to the third, I'm going to write a u. So if I rewrite it, I would rewrite it as 3 u squared minus 11 u. See what I'm doing here?
Right.
Is it minus 4?
Mm-hmm.
Now I have an equation that I can handle. It's quadratic. I could complete the square.
Perfectly legal.
Yep. So in the meantime, so I'm just doing this, I'll say in the meantime, temporarily.
Okay.
Right? So now I'm going to solve for u, which you should be able to do.
Right.
And then I'm going to end up with two answers here, right?
Mm-hmm.
U equals something and u equals something, but ultimately I want to solve for x. So now I'm going to back substitute. Instead of u, I'm going to say x to the 1/3 equals whatever that thing is, and then solve for x. I'm making,
So you're,
I'm doing,
separating these out.
yeah, I'm making the something with the fractional exponent into something that doesn't have a fraction, and just so I can do my solving, and then I'm substituting back in.
Okay.
The other way to do that would flat out be to see if you can factor it in your head, where you take 3x to the 2/3 minus, and you might be able to do this, minus 4, and just go like this, and see if you can factor it.
Okay.
You know what I mean? That would be the shortcut, but if you can't quite see it, then the substitution really helps. There's examples of these in your textbook. I'll track one down quick so I can show it to you. Oh, where am I at here? Stacks. So just a reminder for you guys know you have all kinds of resources for this kind of stuff beyond just, Jamie in class, right? You have a textbook, you have the videos that'll help on the quizzes where you go on Blackboard. But notice if I go to section 2.6 of the textbook we're using right now, this is that algebra textbook that I said we're just using for this first chapter. Solving equations with rational exponents, factoring, radical equations, absolute value. This is what we just talked about, right? So if you scroll through, example 2.51, there's a rational exponent example, and you'll see some examples there. If you keep going, here's some factoring. Solving a polynomial by factoring. Notice this example is almost identical to number 1 that you guys just did, right? If you go down, there's another one. Solving by grouping. This one is almost identical to number 2 that I gave you on that PowerPoint, right? So that would be a good example to look at. The one Harmony and I was just talking about, I don't remember what number that was, Harmony. It's probably the most complicated one on the whole darn list. And I'm trying to think if I have other types of equations. It says solving equations that are quadratic in form. They kind of have the form of a quadratic, but not really. So an example there would be this one here. See if there's one with fractions. Where am I at here? They don't have a perfect example that matches up with the one Harmony and I was just talking about. But these examples will help. So again, the resources are out there. It's just a matter of how much time do you need to put in with practicing, watching videos, looking at your textbook. But we got 11 minutes left to keep working, so flag me down if you have questions. Were you able to factor that one in your head at all? Mm-hmm. Let me know when you have an answer. I'm going to see if it matches what I got.
Yeah, I got it.
Okay, let me...
Yeah, that's what I got.
Negative 1/27th and 64?
Yeah.
Nice. Very nice. That's pretty complicated. If you can successfully do all of these without tons of heavy lifting, you are doing really well. Because these are pretty complicated. These take a lot of thought and a lot of time and a lot of review.
Very far, but I know this is where I have to take out
Yep.
x's. Do I have to start with which? I know all the variables don't have an x, so I can't really take it out of all of them.
Exactly. So you're going to have to group. I see 4 terms there. So you're probably going to have to pair them up. So you could pair them up the way that you have it. Like, just focus on like the first 2. I don't think you're going to get to your triple parentheses yet.
Right.
That's going to come later. So if you just said, I'm going to group the first 2, what do those 2 have in common?
2 x's.
Yeah, so pull out a 2x, and then what's left over? Or no, not a 2x, x squared.
X squared.
Yeah, an x squared.
So then 2x, and then just 3.
Correct, and that's times x squared, right? So, because you got the x squared doesn't just go away, you just factored it out. So you should have that 2x plus 3 in parentheses times x squared.
Because that's what I took out.
Right, because that's what you took out. So now if you were to distribute it back through, you'd get right back to where you were.
Right, so I do
So-
these 2.
Yeah, so what are you going to pull out of it?
Negative 8.
No, I don't think you can pull an 8 out of 12, so go smaller. Negative
4.
So yeah, so go minus 4. Now keep in mind that it's not multiplied by this guy though, right? Yeah, so this is where it just takes a little bit of fluency here. You said, I'm gonna, first of all, you probably moved it all to the same side, right? Minus 8x minus 12, right? You said, I'm going to group these 2 here, and then I'm going to group these 2 here. So you went x squared, you pulled an x squared out, and the leftover was 2x plus 3. Correct?
Yep.
Okay. Now, notice that there's no times sign here.
No.
They're not multiplied. So I got to go, now I'm going to group these guys. What are you going to pull out? A minus 4?
Yep.
So minus 4, what's left over?
4x.
Nope. Wouldn't it be 2x because negative 4 times 2 is negative 8? It'd be 2x. Nope. Negative 4 times what gives me negative 12?
3.
Plus 3, right?
Oh.
So I'm almost there. I started with 4 guys. 1, 2, 3, 4 guys. I'm now down to 2 guys. 1, 2. Eventually, I need it to all be multiplication. So I need to get rid of this negative sign. But notice, what do my 2 guys have in common now? 2x plus 3. Both of them own a 2x plus 3. So if I take a 2x plus 3 out of both of them, What's left over? This guy has an x squared. And what does this guy have? Negative 4. So I'm almost there. I need 3 parentheses, right? Here's one of them. This guy I can turn into 2. Can you factor that guy? What 2 factors would give me x squared minus 4? 2 and negative 2. Very good. 2 and negative 2. Now I have my 3 parentheses. So for those of you that were working on this one, this was number 2, right? Once you get down to your 3 parentheses, you should be able to handle this. Obviously, one of my answers is 2. One of my answers is negative 2. And then this one, I got to set it equal to 0, so it'd be 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 halves. Or negative 1.5 is my third answer. Earlier, when I was showing you that PowerPoint, I said we're going to do 3rd degree and 4th degree and 5th degree. Not all of them work out nicely. Remember, some of them are so awful and ugly that you would never be able to do this by hand. You would have to pull out a graphing calculator or something. For example, if this 12 right here, if I just change this to a 13, none of this works. It is unfactorable, right? This is what we would call a contrived problem. This was specifically set up so that a human could factor it. If I change that to a 13, your answers are square roots and awful decimals, and you would never be able to solve that problem. So again, it was set up for you to be able to do it. Question over here.
I erased what I did because what you did made more sense than what we did.
And again, there's multiple ways to get there.
Okay, but
Yep.
we divided everything by 2.
Okay.
Yep.
And then
Which is
got-
perfectly legal.
Yeah.
Yep.
But then we were left with like x to the 3rd plus 1/2 x squared.
1.5, right? 1.5.
Yeah.
Yep.
And then it just got really ugly and we didn't know how to factor.
Yeah, so you basically changed, I mean, that helped you here, here, and here, but then you changed a whole number into a fraction, which probably complicates things. I'm not saying it's bad or wrong. It's just sometimes you got to plot your attack and ask yourself, am I really making things better or am I making things worse? And that just comes with practice and experience, and right? Yeah, sometimes we do algebraic maneuvers that are perfectly legal, but they actually made the situation worse as opposed to better. And that's where you just need a little bit of experience. Okay, so we got 2 minutes left. I have a document that has the solutions to all of these, by the way. Okay, and here it is. I'm going to post it to Blackboard right now. So it's up to you. Remember, I'm not asking you to hand this in, right? So I would suggest you just practice your way through this and see what you can do. And when you're ready to see, it didn't come up. When you're ready to see what did Jamie do, how did Jamie solve it, you'll be able to access the document and you'll say, oh, that's how Jamie did it, right? Ultimately, I'm not having you hand this in. What do you have to do? Your 2.6 quiz, which has a lot of these on it, right? So you're going to get some practice and obviously a grade on that portion. Yes?
Where did your x squared go?
Let's see. From here to here?
Yeah.
I said both of these guys, both of them,
Yeah.
have a 2x plus 3 in common. So I pulled out the 2x plus 3, and what's left over? X squared and minus 4.
I know that. I remember.
There you go. Yep.
Okay.
Okay. Flag me down if you want to talk about life in general. Otherwise, have a good weekend, and we'll see you on Monday.